The key idea of cloud is that we want to investigate the connection between cosmic rays and cloud droplets or ice particles. And to do that, we're using the CERN PS beam as an artificial adjustable source of cosmic rays. And then we have a large chamber which we've built, to which we attach a lot of very sensitive instruments, where we recreate the atmosphere. And we want to look at the effect of the beam on creating the seeds for cloud droplets, and in fact creating the droplets and ice particles themselves.
I'm Markku Kulmala, professor in physics in the University of Helsinki, and I'm part of this cloud consortium. I'm responsible for cluster measurements and interpretation of physics results. I'm here at CERN since the cloud experiments is here, and the cloud experiments is at CERN since CERN is actually the only place in the world where we can get a very well-defined cosmic ray induced ionization in let's say real time and real concentrations what we can see in atmosphere.
One of the challenges on cloud is we want to create a column of ultraviolet light in the chamber to recreate photolytic processes, chemical reactions, photolytic chemical reactions in the chamber. Anyway, it turns out all the previous experiments that have done that have shone in big, powerful lamps into the chamber, and the heat that they've put into the chamber has given spurious results. So we have designed a fiber optic system that only brings light in and no parasitic heat. But that has crucially depended on these little optical feed-throughs that feed through the walls of the chamber. That has taken absolutely the limit of CERN's capabilities in terms of bonding quartz fibers to welding them inside small ferrules, making the proper seals, and finally sealing them in the chamber. I have to mention one person in particular here, actually, and that's Serge Matteau, who's one of the key people involved in this here at CERN. But this is one small example, and it's taken a huge amount of effort, but it's finally been very successful. But you could multiply that by a dozen or 20, and that would be, there's many, many different parts of cloud involved. All these processes in the atmosphere, of which Markku is the great expert actually, they're highly non-linear. So we have to do the experiments at conditions as close as possible to atmospheric conditions. And the CERN PS beam actually very nicely reproduces the energies of cosmic rays at low altitudes in the atmosphere. So it's the perfect beam, and it has just the right range of intensities that we need.
It's the only beam in Europe where we can make this kind of well-defined experiments. And also I think that without having it here, it will never happen. I think that this is very important that it's right here, the place where we have our chamber, where we get this beam. And besides the beam, there is a good experience of making this kind of big physics efforts.
Yeah.
And then also to collect teams around Europe. This system what CERN has experienced for decades is good way to collect knowledge from and experience from different laboratories around Europe. And that's why I have been very keen on being here and using that beam from very beginning. And I think that we met first time 97 or so when he came in with his ideas what should be done, and we had very nice physics discussions, and then we have get other people interested in, and now we are here, and we are certainly waiting the best, let's say, atmospheric physics experiments what has been done so far.
We expect to have the first results next year. And in fact, the results should emerge, at least we should see first indications very quickly online as to what we're finding, although the careful quantitative analysis takes longer. But the results come fairly quickly.